Is it possible that life began on Earth before we thought Earth was even ready for it? More than 4 billion years ago, the crust of the Earth was still cooling. The oceans are only beginning to form. And if an asteroid crashed into us, that wasn't a big deal. That was like Tuesday. But in recent years, we've started to discover that even in this hellish environment, life found a way. The search for the earliest signs of life on our planet has always been controversial, because the further back you go in time, the less evidence there is to find. Rocks get weathered and melted down and totally transformed by heat and pressure. And as those old rocks are destroyed, so are the fossils they might hold. So right now, the oldest definitive fossils that we know about are in Western Australia. They're stromatolites, formed by mats of bacteria 3.5 billion years ago. That's about a half billion years after the Hadean Eon gave way to the Archean, when life as we know it was just getting big enough to actually see. But of course, no one was around to actually see it, because there were no eyes or light sensing organs or, Anyway, so picture an ancient Archean shoreline. There's barely any oxygen in the air. And under your feet at the water's edge is this greenish black slime, and lots of it. That slime might stretch as far as you can see, even forming mounds in the shallow water. But that slime is actually made up of colonies of microorganisms like cyanobacteria, which are happily metabolizing carbon dioxide into oxygen. Over time, these giant mats of microbes trap a bunch of sediment and fossilize, forming the oldest fossils we've ever found. But scientists think that life is probably even older than that. Some recent discoveries have pushed back the evidence of life to about 4 billion years ago. But these finds don't involve fossils at all, at least not as we usually think of them. Instead, what they're finding is microscopic chemical evidence of life in the form of biogenic carbon. That's carbon that was once used by and was part of living things. In order to understand what makes biogenic carbon so special, you first got to get to know carbon itself, the most important element in the history of life. An atom of carbon always has 6 protons in its nucleus. It usually has 6 neutrons too, but sometimes a 7th or even an 8th neutron sneaks in there. Atoms with these various numbers of neutrons are known as isotopes. So the 6 neutron isotope of carbon is called carbon-12, with 6 protons and 6 neutrons. If it has 7 neutrons, then it's carbon-13. Now what's important to paleontologists is that all living things have this funny preference for carbon-12 over any other isotope of carbon. Carbon-12 makes up 99% of all the carbon on Earth, so you'd expect to see it around a lot anyway. But because it has 1 less neutron than carbon-13, it's lighter and easier for our cells to use. And our cells use them with the help of enzymes. Almost all living things, you, me, trees, bacteria, wildebeest, they all use enzymes to make things like fats and proteins, the stuff that life is made of. So let's say the enzymes in some microbe bump into atoms of carbon-12. Those atoms will be easier for the enzymes to take up and incorporate, but the carbon-13 tends to get left behind. As a result, that microbe will have a much lower ratio of carbon-13 to carbon-12 than something that was never alive. Specifically, that ratio will be 25% lower. That minus 25% ratio means that what you're looking at is probably biogenic carbon. So that's what scientists are looking for when they're searching for the earliest signs of life on Earth. Now, in order to find super old biogenic carbon, you need super old rocks. And rock outcrops that are older than 3.5 billion years are hard to come by. But a belt of rocks in southwestern Greenland is one of those places, where exposed bedrock has been dated to 3.76 billion years old. And there in 2013, a team of Japanese scientists found that the best preserved of these rocks contain biogenic carbon, with that same ratio of carbon-13 to carbon-12 that all living things have. More recently, in 2017, another team reported finding biogenic carbon in rocks from Labrador, Canada that were an astonishing 3.95 billion years old. Now, those findings are still highly debated, but if they were confirmed, it would mean that life was around when those Canadian rocks formed way back when the Hadean Eon had just ended. But the potentially oldest biogenic carbon ever found goes back even further. It was found trapped inside a single crystal of zircon from the Jack Hills of Western Australia. Zircons are tiny crystals made of silicon, oxygen, and zirconium, and they're practically indestructible. While most rocks haven't been able to last 4 billion years, sometimes zircon crystals do. And in 2015, researchers found a bit of carbon inside this single Australian crystal that was 4.1 billion years old. And sure enough, the sample had the same ratio of carbon-13 to carbon-12 as biogenic carbon. So could this mean that there was life on Earth 4.1 billion years ago, back in the Hadean Eon, when Earth wasn't, ready to come out of the oven? Well, a single crystal doesn't come anywhere close to proving that, and the researchers don't say that it does. Instead, they say it's just another clue, but it's an important one, about how biogenic carbon could unlock the secrets about the origins of life. But there's still a question hanging around in the background of all this, which is, what kind of life could have left these traces of carbon? What could life have possibly looked like 4 billion years ago? Well, we know that even in the early Archean, Earth was still a pretty hostile place, what with all the asteroid impacts and the lack of oxygen in the atmosphere. So the biogenic carbon that's been found could be the remains of cyanobacteria, which is bacteria that use photosynthesis to live anaerobically in an oxygen-poor environment. Or maybe they were chemoautotrophs, microbes that metabolized inorganic chemicals for energy instead of using sunlight. It's hard to say. And maybe the Hadean was actually a lot less hostile than we always thought. We're just not sure. But it's looking more and more likely that life on Earth goes back all the way to the Hadean Eon, more than 4 billion years ago. which means life may have been around for almost the entire history of the planet. And we're able to learn that remarkable story without fossils, just by counting the neutrons in carbon. Now, what do you want to know about the story of life on Earth? Let us know in the comments, and don't forget to go to youtube.com/eons and subscribe. And the fun doesn't end here. Do yourself a favor and check out some of our sister channels from PBS Digital Studios.